I come from Cabo Verde, but actually I am in China to do my PhD degree in Hubei province. Here, what I want to do what we do in this research, sometimes have some high buildings. When it's happen a fire, a lot of people can die, but it's not because of fire. Sometimes it's because of smoke. Don't know how to escape, and sometimes have some signals. It's on the top, and you cannot read. And have some buildings. Sometimes the signal is on the bottom. This is better because the smoke it's go up, and this is important. How to make the good visibility in the timing when you want to escape. In this introduction, our goals it is improve the visibility of the evacuation by controlling the smoke based on ventilation system to enforce the desired requirements. What is the mean? We try to do here because have a different ventilation system in some buildings. Sometimes the people use the pressurization, sometimes the people use the natural ventilation. The architects like the natural ventilation, not the conduct, not that things. But sometimes this is not a good way. And here we make a study about the three ventilation system, and we try to find who is the better to use in high buildings, maybe more than 24 floors. This is the building in Wuhan. Maybe they'll have some Chinese people here can know this building. It's in Jianghu. This building is a technology department in Wuhan University, and this building have the number of floors is 21, and the area is 2,060 meters square. Here, this is our modeling. This is just a case study about what we do. This is our model in the FDS. We do the same building, but how is the stairwell? Here we can see we have four stairwell to make the evacuation of the people, but have an elevator because when happen a fire, is not recommended to use the elevator. Then we study just one stairwell, and if this our study proves something in one stairwell, this is the same for other stairwell. This is this code, this document in the China's document show some size for the minimal exit about some buildings. In the hospital, we can use the minimal 1.3 meters, or for apartments 1.1, and for other buildings 1.2 meters. And the building, what we do the study, we can see that this building is already exist. It's not a project. We can say if it doesn't work, we can rectify the project. This building exists. We want to clarify if what we do, maybe if something is wrong in this building, I don't think sure these guys will broke something to change again, but we want to test if this is work. That analysis we do here. This is to compare the document in the regulation, the Chinese, to the real building we make the research. Here, we try to simulate, and our simulate is the 12th floor. In the lobby, we simulate if have a fire in this space, what's happened about the smoke in this stairwell. This is the close in the that blue color. This is init regions to define the indoor temperature, because we have indoor. This study is in winter, and outside we have -3 degrees Celsius, and indoor we have 18 degrees Celsius. This is mean we have a very big difference temperature between outside and inside, and the measure of the door and the window for the open surface. Here we use this measure to show, because in this 3 ventilation system we should study 3 cases: when everything is closed, when everything is semi-closed, and when all the door and the window is open. In this case, we have the other measure when everything is closed. If everything is closed, sometimes we have some, how do I say, some little part is not full closed. Then you can have some lake air to flow. Then we should calculate everything. If everything is closed, it's like this. If everything is it's open, we have full door open, but the window is slicing, aluminum slicing moving, then just you have half window open. And for the semi-open, we use here alternate floors to use this. And in the final, we can see the total area of the ventilation, the natural ventilation. For the natural ventilation, here the study is done without preventing any measure, because we just use the natural ventilation. Then we cannot control how many pressures about the window, the air we will put in the stairwell, or how is the measure we can exhaust the stairwell. Here is for the pressurization. For use the pressurization, we use some conducts, and this is the value we use. It's 18,000 meters cube per hour, and through the 5 fans. These fans, we use just 5 fans because the building have 21 floors, but we just make the simulation in the 5 in the floors near to the zone have the occurred the fire. For the dilution, we use some exhaust, and we should clarify the exhaust should take off the pressurization in the same quantity like a pressurization supply the air for indoor the stairwell. Here we talk about the visibility just in case of natural ventilation. If we have natural ventilation, we can see in the bar. Here we have better visibility, and here we have a bad visibility. And this is, if we see in the 12th floor, when has happened the fire, the smoke will, in natural ventilation, here we have everything is closed, the window and the door, it's closed. Then we have a bad visibility in this floor. But here we can have, I'm thinking the value, we can see the next slide, we can see on graphic, here we have a better visibility. In semi-open, it's better. In open, in natural ventilation, we can see the visibility, it's increasing. It's raised, the visibility. And this is better if you have a natural ventilation and everything is open in natural ventilation. But something will change in the next video. The visibility in case of pressurization, it's similar. It's quite similar to the natural ventilation, because when you push some air for inside, and you can push the smoke, but you have other problem. You can make some pressurization, and you cannot open the door, and we should understand and worry a little bit about this. The visibility in the dilution system, I think it's better. We can see in the next graphic, because here, sometimes if we just analyze the color, we think the visibility is not good. But if we see the value in that bar, we can see that this value it will be better than other ventilation system. Here we have the pyrosim. Maybe the last version can do you can mix the graphic, but in fact, I will be honest, I didn't do the graphic. I think the pyrosim doesn't do this, make a true graphics together. Pathfinder, I think so, but the pyrosim didn't do. Then we take all the results and the value. This is an Excel graphic to show what has happened in that visibility. We can see natural ventilation system. We can see the closed, when in natural ventilation, if everything is closed, from 10 until 14 floor, the visibility is less than 5 meters, but we can see it. We can see in the first here. The last document I already talked, the regulation in China. This guy's point 5 meters for the people unfamiliar with that building, and the 3 meters for the people now the building. Then we have 2 different people to evacuate. We have people who don't know that building. It's the first time in that building, and the visibility is minus than the people now the building. Maybe the people work in that building every day. He's a family without visibility, but can try to evacuate better than the people don't know. And this is mean here in the. This is mean here we have the less than 5 meters, and this is something doesn't match here. In the 5th floor and the 16th floor, the visibility is very around 10 meters, slightly less than the required and the code. And from the 17 and to 18, to other floor, the visibility exceeds 18 meters, and this is better than another. We can compare this with this document to prove what the visibilities have. The pressurization system, we can see in the graph, we can see we have a closed and semi-open and open, and 3 different cases for 3 different for one system ventilation system, right? Here we can see between the 12 and the 16th floor, the visibility is less than 5 meters, and 17 and 18 is between 5 to 13 meters, and the others is more than 25. Then we can, if we still to analyze this graphic, we can see the dilution have a better conditions to visibility here, except the 13 and 18 floor with less than 3.5 meters to 9.45 meters allowing. Without, not without, the pressurization tool, it's analyzed in this research because we see the visibility, but we need understand not just understand who is the good ventilation system to use, but we need to know the pressurization, because if you want to evacuate, if you have a good visibility, but you need to evacuate too. And if you need to evacuate, you need now the pressurization, because sometimes have a stake effect in the downstairs. We have a negative pressurization, and downstairs and upstairs we have a high pressurization. And this effect will be very according to the number of the floor. And sometimes if the building is so high, and you can have a strong pressurization, and it's difficult to open the door to escape in that case. The different pressurization in the pressurization system, we can see here we have something is not good, because the pressurization in the downstairs is -3 PA, and the top it's however tends to achieve to 70 PA on the top, and this is dangerous for to open the door. In the dilution, something is more light, and we can see it is better than other two different ventilation systems. Here we just concluded when we reminded the burning. That burning we use in this research is just a 4.5 minutes, and we use the this is a 5-minute simulation, but we test in the 4.5 that results, and we get we can see in the below to 12th floor, mean that if the fire appear in this story, the smoke will quickly spread on the stair. Here, this is I think the future with the machine we use sometimes make a difference between your results, and because this I put this topic here to show the future of the machine we use to make this simulation. Sometimes I'm thinking if you have a top machine, you will get better results in your graphic or in your results. The summary of results, the ventilation system, natural ventilation and pressurization, dilution. We can see the visibility and the pressurization, the differential pressurization. If in natural ventilation, the visibility is unacceptable, because the graphic, if we see the graphic again, we can see this is not good. But for pressurization, it's very good. Dilution is acceptable, but it's change. In case of pressurization, the dilution is the better. Then we can raise the visibility, but we have problems sometimes in the pressurization. And pressurization, I think it's more dangerous, because if you cannot open the door, it's dangerous for evacuate. But the visibility, it's important too. We should think in this together, because sometimes the visibility, it makes some people panic, or sometimes some people fall on the stair. And this is the only way to escape in the buildings, because it's not recommended to use an elevator when you have a fire. Then you have just one choice, and this choice you don't have a visibility, and this will be the people. Okay, in this sense, I just make some conclusion about that table to understand the results analysis. And for conclusions, we think the dilution system is the ventilation system better to use for raise the visibility. And about I'm talking about something about the evacuated people. For better, we should, if we have a high building, we should make some place between the stairwell, to like cut the stairwell, not make it so long, and make some space to broke this stake effect. Because if you have this like some tunnel, and you should broke this in the middle and make some space, because the stake effect will be dangerous, because the pressurization don't let you open the door. I am not sure my English is clear, but I try my best. And if you have some questions, I am here to try to answer, or can read my paper, maybe I understand better. Because this is my first time in America, and speak English here is strange for me, and we don't speak in our country English. Thank you.
Thank you.
Yeah.
So we have time for one quick question if somebody has it. Otherwise, we'll move to the next talk. Anyone? No? Okay. Oh, okay.
So which grid size did you choose?
What?
Which grid size did you choose for your model?
Which size?
Which size of the grid did you choose? Which mesh size?
Resource?
The mesh, how big was your mesh? 5 centimeters, 20 centimeters?
Oh, for my for the simulation fire.
Yeah.
I didn't define the size, but I defined the kilowatts is 500 megawatts. What? It's near to the it's the size the I say wow, fuck, man. It's the size the same to the stairwell. Maybe it is. It's a little bit, because sometimes if you want to connect the mesh, you should take care of the cells. Then sometimes you will lose some size, and I put near the stairwell. Yeah, okay.
Okay, well, thanks again. I appreciate this.